IGCSE Computer Science. This is syllabus statement 1.3.1d. Produce a logic circuit to solve a given problem or to implement a given written logic statement. So this video is, as the syllabus statement says, we're going to be creating logic circuits using, logic statements or a given problem. So we'll start with the logic statement because it's easier. I wouldn't say it's easier. They're about the same, but yeah, it's simpler just so you can get the idea. So let's go ahead and get started. So here we have a condition. X is 1 if A is 1 and B is 1, or A is 1 and C is 0. Here we have the logic statement, X equals A and B, or A and not C. Then we have the Boolean algebra, X equals A and B, or A and not C. So we're going to create a logic circuit using this. Yay! So what you're going to do first is you're going to do the brackets first. I'm just going to put my computer on charge. Okay, so yeah, do the brackets first. So we start with A and B. So we have A here, B here. Let's add an AND. So we have A and B. So there we are, that was easy. Next bracket, A and not C. Okay, so I'm just going to move this up here. So it's a little bit, in fact, I'm going to get rid of this and draw this again. Alright, so it's A and not C. So let's start with the not C first. So we need a NOT gate. Attach that onto C. Then we have A and not C. So we need an AND gate. And this will connect, of course, C, or rather, not C, and A. Now note the use of this circle here, and that basically means that this wire is connected with this, and this has no circle because the wires are just crossing, they're not connected. So make sure that you do this in the exam when they ask you to, if they ask you to draw a logic circuit, because that'll come in handy if you're building big circuits and crossing wires and such. So yeah, so now that we're done with our two brackets, we can move on to the rest. So that's the OR right here. So we just add it here, and we drag it here and here. And then we can extend that to the output. So we can give this a try. So it should work. A and B should work. So that works. A and B. A and not C, that works, because A and C wouldn't work. And we can also try some other things like B, C and B, some other stuff. If all of them were on, then that would be on. If it was just A and B, that would be on. Well, actually, yeah, it's A and B, right? Yeah, it's supposed to work. Yeah, if all of them were on, then that would also work. Okay, so that's pretty much it. We've built our logic circuit. So what next? Well, we create the truth table. Now, to save you some trouble, we actually could create assign intermediate values here, here, and here, and then trace the wires and see where what outputs and what inputs into where, and well, we don't have to worry about that because I'm going to teach you how to fill in a truth table with just the logic statement. So let's go ahead and go to another app, Numbers, and we can do that. So I keep forgetting okay, so X equals A and B, or A and not C. So let me just write that up somewhere here. Just put it here. X equals, was it A and B, or A and not C. So that's our, what's put up here, that's our statement, and we're going to create the truth table with this. So we need the inputs A, B, and C, and we need the output X. So here's how you do it. first you can fill these in with the numbers. 1, 1, 1. We need another one. 0, 0, 1, 1, 0, 1, 1. I could probably do this. No, that doesn't work. Let's try that. No, that's not the. This is annoying. Let's try this. Okay, alright, never mind. We'll just continue this. Okay. And then we 0, 0, 1, 1. This better work. Yay. Okay. So, created our all possible inputs. So now, again, we look at the brackets, A and B. Let's find where A and B are 1. So, that's 1. And that's another 1. And let's find A and not C. There's 1. And the rest should be 0. Or is it? Yeah, I think that's pretty much it. And we can test it. So if we remember we can remember 0, 0, 0, 0, 1, 0, 1, 1, 0, 0, 0, 0, 1, 0, 1, 1, and that works. Check that out. It actually works. So, again, just a tip, if you don't want to waste your time tracing the wires and the logic circuits, you can just do that if you're given a logic statement. So what we're going to look at now is another sort of, we're not the statement, but we're going to look at a problem. So I've got one here. A gas fire has a safety circuit made up of logic gates. It generates an alarm, X equals 1, in response to certain conditions. And here are the conditions. And yeah, so, didn't mean to do that. This question I took from the 2015 exam from May, June. And I think it's a pretty good question as an example because it's exam style and you can get used to how the questions are worded. So let's go ahead and do this. So we need to remember this, and then we need to remember G and so we need to remember G and 0. Well, G and C. So G equals 1 and C equals 0. So G and not C. So I'm just having trouble following everything. So let's have that. X equals was it G and not C? There was an or, I believe. Or C and not L. So it's or C and not L. Yeah, I probably should have planned that before having to waste my time doing that. So let me just check that. G and not C. G and not C. Or C and not L. And that should work. Alright. So we can go ahead and we can get rid of these because we're going to be replacing them with the actual letters. So we need G, C, and L. Just move those. And X stays the same. So we just have to get rid of these gates here. Get rid of that, that, and that. And we can start fresh. So let's go ahead and do this. Let's again work the brackets first. G and not C. So let's have the not in front of C. And make sure it's a little bit far because there is a C here. So just move that there. And we can have the AND gate here. Just move that there and move that there. And then C and not L. So we need another NOT gate. An AND gate. And an OR gate because there's one right here. So just do that, that, and ew, that. I'm just gonna move this down. Okay, so there's our circuit for this problem. So again, we can test it out. G and not C. So G and not C, that works. C and not L, that works. And a few others which may or may not work. So again, we're going to do the, we'll create the truth table for this. So let's go back to numbers. So that's G and not C, or C and not L. So we can clear just this up, and we can do the same thing we did with the last one. So G and not C, and we better actually change these as well. That would be a good idea. So G and not C, that's one there, one there. Or C and not L, find C, not L, C, not L, and the rest should be zeros. So let's go ahead and test this out again. I'm going to see if I can memorize this. 0, 0, 1, 0, 1, 1, 1, 0. So 0, 0, 1, 0, 1, 1, 1, 0. I'm horrible at memorizing. What was it again? No, I'm not kidding. I'm actually serious. Okay, let's start. Let's do half and half. 0, 0, 1, 0. So 0, 0, 1, 0. That works. 1, 1, 1, 0. So 1, 1, 1, 0. So see, that worked again. So yeah, that just can save you some time in the exam. And in the next video, we're going to be looking at the NAND gate and why it's so special. That's it.